Доброго дня! Сьогодні ми розглянемо історію розвитку лабораторної медицини та перспективи її вдосконалення в Україні. Вашій увазі пропонується серія лекцій магістра медицини Університету Арканзас Лінсі Кларк.
Hey everybody, okay, we've made it to lecture 2. Woo! So for those of you that remember from lecture 1, I have a background in history. My first bachelor's degree is in history, so I find that it is very important to know the history of laboratory science. I realize that some of you will really enjoy this, and some of you are not history people, and you may not enjoy it as much, but I do think that you'll learn at least something kind of fun in this lecture. So hopefully we can make this a little bit fun for you guys. So as usual, we will start with our objectives. First objective is to define laboratory science and discuss its importance in healthcare. Number 2, discuss the history of medical laboratory science and technology from ancient Egyptian times through the 20th century. That's right, we're going to cover a lot of ground today. Number 3, explain the origins of professional certification in the laboratory sciences. And number 4, identify early aspects of the quality movement in the laboratory. So laboratory science as a profession. We're going to define laboratory science. And the definition is just the medical discipline by which clinical lab science and technology are applied to the care of patients. Now we're going to talk about the history of our profession and how our profession came to be. So laboratory science was not recognized as a profession until the early 20th century, and it wasn't until 1995, exclamation point, that the National Labor Relations Board deemed medical laboratory scientists as professional employees. So really, our field has not been considered a professional field for all that long. However, laboratory testing dates back to ancient times. So it's been around for a really long time. And some of the earliest known tests were done on urine. So early history of laboratory science. Some of the earliest physicians in ancient Egypt, Mesopotamia, and Greece began basing diagnoses and treatments on observations of clinical symptoms of patients. They also started the practice of examining patient specimens, and mostly they were examining urine. One of the oldest known tests on urine in ancient times involved pouring the urine on the ground to see if it attracted insects. If it did, the patient was diagnosed with boils. And despite my extensive research, I am not sure what boils means exactly. It could be the plague, it could be some other strange illness. But the point is that was sort of an early sort of lab test. So around 300 BC, Hippocrates developed some of the earliest known diagnostic protocols for patients. He was also the first to correlate bubbly or foamy urine with kidney disease. So if you guys that work in the lab now, if you have a urine come in that's got high protein in it, if you shake that urine up, you'll notice that it gets real bubbly. And for my on-campus students, I'll be sure to show you that when we are in urinalysis lab. So moving on, Egyptian physicians, they described urinary symptoms and were among the first to mention hematuria, meaning blood in the urine. And they thought this was associated with schistosoma, which is a parasite, or stones. And as we know, both of these can cause blood in your urine. So the photo on the right, if you look at that, it just shows some hieroglyphs that represent various Egyptian terms for urine. And if you look closely, you will notice some of the symbols they used are rather phallic. So pretty interesting little symbols there. Okay, moving into the Middle Ages. We begin to see urine used as a diagnostic aid during the Middle Ages. Isaac Judius is credited with writing the first book detailing characteristics of urine. He included color, density, quality, sediment, things of that nature. Urine became such an important diagnostic tool during this time that physicians who didn't examine a patient's urine were actually subject to public beatings per the Jerusalem Code of 1090. So they actually had this law written that you could be publicly beaten as a physician if you failed to examine a patient's urine, which very much speaks to the importance of lab testing already, even back in ancient times. So the examination of urine at this time was nearly universal in European medicine by 1300 AD. And this photos here on the left are some drawings of urine flasks that show different colors of urine with what is presumably explanations for the different colorations. So if you look up in the top left, you've got kind of an orangish, the bottom is kind of a brownish goldish, and then the one on the far right is kind of red. So presumably that would be kind of bloody urine. Okay, so we're going to talk about the early history of the microscope now. The invention of the microscope obviously has had a huge impact on the field of lab science, and what started out as a relatively simple instrument is now a widely used instrument in the lab. Many departments use it, and they use it every day, all day. So the microscope was first invented in the late 16th century, but who exactly invented it is a topic of debate among historians. Most historians credit Hans and Zacharias Janssen, which I'm sure is pronounced some other way, but I'm going to pronounce it my southern way. So the Janssens were a father and son team that are credited with inventing this very simple microscope. And if you look at the top left of this slide, there's a photo there of a compound microscope, and that would be like the one that the Janssens invented. So you can see it's just a simple tube with some lenses in it that magnified whatever you're looking at, and it's pretty simple. But as the years went on, lots of new technologies became available, and so the microscope also was reinvented again and again to become more sophisticated. Over the years, the microscope has been used in many scientific discoveries. So the next scientist we're going to talk about, Kircher, he studied disease causation, and during his studies he found what he thought were worms in the patient's blood of patients that had the plague. What he likely observed was probably pus cells and red blood cell membranes. It would have been nearly impossible for him to detect such a small bacteria, Yersinia pestis, which is what causes plague, with such a low power microscope. And the microscope that he was using was probably about a 32 power microscope. So the next scientist, we've all heard of Antony van Leeuwenhoek. He's known as the father of microbiology. And he was really among the first to observe bacteria and protozoa using a microscope. And so if you look in the top right-hand corner of this slide, there's another photo of a microscope, and this would be the microscope like the one that Robert Hooke invented. It was more sophisticated than the Janssen microscope, and this one actually included an oil lamp for light and a focusing knob. Hooke used this microscope to observe what he termed cells in vegetables, fossils, and he looked at also thin slices of cork. And he was the one that actually gave cells their name of cells, which is the name that we still use today. And his cell theory paved the way for more discoveries by scientists that came after him, such as Marcello Malpighi. I'm probably butchering that last name, but y'all get the idea. He used the microscope to study embryology using baby chickens, little baby chicks. And he examined their organs and tissues, and he's actually considered the founder of histology. Okay, starting with the 17th century, we're now going to discuss the history of lab science from then up until today. So we're going to cover a broad range here. We're just going to hit the highlights, and I'm going to talk about some key points that are, in my opinion, very important to the growth of lab sciences and to the history of our field. So in the mid-17th century, Richard Lower began to experiment with blood transfusions. So think about that. 17th century, 1600s, that's a long time ago. He started with direct transfusion from one animal to another. I believe he used dogs for this. But then he also transfused the blood of a sheep directly into a human, which if you look at the photo on the left, he was you can see him there with the little lamb transfusing the blood into the human. It's kind of creepy. Anyway, so he was the first to really recognize the need for blood transfusions and was really a pioneer in the field. And then Thomas Willis was another important figure in the 17th century. He was an English physician, and he advanced urinalysis methods and developed new urinalysis methods. He was the first one to note the characteristic sweet taste of urine from diabetic patients. This eventually helped to establish a differential diagnosis between diabetes mellitus and diabetes insipidus. So when you hear about people that used to taste urine as part of the lab testing, this guy is responsible for that. Super gross. So also in the 17th century, urinalysis practices began to include things like gravimetric analysis, or like specific gravity measurements. And it was discovered that when you boiled urine with acetic acid, if it contained protein, it would form a precipitate. So they were able to determine in that way if urine had protein in it. So moving on to the 18th century, medical theory, then medical practice. So new textbooks emerged, and they documented new diseases and new drugs that were available. But even though advances were being made in treatments, hospitals were still super dirty, and it was still really common for patients to die from sepsis after surgery. So some of the notable scientists in the 18th century include William Hewson, J.W. Ticky, Matthew Dobson, and Francis Home. So the father of hematology, which is William Hewson, he did a lot of studies that led to better understanding of the process of coagulation, or the clotting process, which we now know a lot more information about. J.W. Ticky was among the first to examine the urine sediment under the microscope. So before, where they examined color, quality, clarity, and all that kind of stuff, now they're actually looking at the sediment as well. And remember, what we see in the sediment is really important to the urinalysis. So remember the guy on the last slide, Willis, that noted the sweet taste of diabetic urine? Well, Matthew Dobson was actually the scientist that proved that that sweet taste was caused by sugar. And then Francis Home actually developed a yeast test that would detect sugar in urine, which hopefully meant that they could stop drinking the pee, but you just never know. Francis Home also published, if you look up there in the top right corner, medical facts and experiments. And interestingly enough, if you Google this, you can read this for free on the Googles, which is pretty neat. So laboratory science in the 19th century. This, in my opinion, is where things really start to get interesting. So if we look at what's going on in the U.S. and around the world, we know that the Industrial Revolution has begun, and the landscape is rapidly changing. We've got international travel possible and more frequent, and that also means international trade is increasing during this time as well. So the late 19th to the early 20th century is commonly referred to as the Progressive Era, so named because of the social, political, and philosophical reforms that took place during this time. The 19th century is also commonly referred to as the era of public health, and that is because in the midst of all these reforms, we start to see a shift from individual to population health. And so the aim was really making progress towards a better society. In addition to more sophisticated industry, during this time we start to also see increasingly sophisticated laboratories and more advanced diagnostic techniques emerging as well. Society was also focused on creating a healthier environment. So the 19th century also brought us water treatment, pasteurization of milk, improved public hygiene, better working and living conditions, better working environments, better physical environments, and that sort of thing. Okay, so what's going on in the lab during the 19th century? Well, we have a lot of discoveries during this time. So we're going to kind of break it up, and we'll start with advances in bacteriology, or microbiology as we call it today for the most part. So as I was saying, society really began to demand cleaner environments and safer food and water during this time, and so this led to the pasteurization of milk, right? So this process was actually developed by Louis Pasteur. We've all heard of Louis Pasteur. But he was also responsible for introducing the concept of aerobic and anaerobic bacteria, and he also produced several vaccines. So if you look at his photo there on the left, this is a photo of Louis Pasteur in his lab, and he's holding a jar which contains the spinal cord of a rabbit infected with rabies. He actually used this while he was developing a rabies vaccine. So kind of neat. Poor little bunny. It's all for science though, right? Okay, so still on the subject of cleanliness, we can move on to Joseph Lister. So Lister devised a new sterilization technique for use in surgery, and he took the germ theory and applied that to the care of surgical patients, and his sterilization technique involved filling a pump sprayer with carbolic acid, which is now known as phenol, which was used in the operating room. So you can see in the middle image there, you can see the pump sprayer next to the patient's bed where the men are operating. And if you look close, you can see the little pump spraying out the carbolic acid. So also, Robert Koch, he also contributed to advances in bacteriology, and he is responsible for developing a process for fixing, drying, and staining slides, as well as a method for obtaining pure cultures. And if you don't already know, obtaining a pure culture is super, super important in being able to identify bacteria. So Koch also discovered Vibrio cholera, which is the microorganism that causes cholera, and he was able to determine its transmission routes. So knowing how diseases are transmitted are very important when you're trying to prevent the spread of disease. So this kind of goes along with better living environment. So if you can prevent the spread of disease, then your population health is better, right? Okay, moving on from bacteriology, let's talk about 19th century advances in hematology. So lots of discovery in micro, also lots of discoveries in hematology. So in 1877, this dude, K. Virord, yeah, we'll go with that, introduced the concept of coagulation time, so a measurement of clotting time. And this is something that we still use today. It's still a very common test that's ordered in the lab today. In addition to this guy, we've got Paul Ehrlich, who, much like Robert Koch, developed a method for fixing, drying, and staining slides. However, Ehrlich developed this method for blood smears rather than microorganisms. He also developed a very early white blood cell classification system, and if you look at this image in the middle, you can sort of see the different white blood cells, and they're stained, and they're all pretty, and it's a very early classification system. Now, later in the 19th century, we have Sir Almroth Wright. Sir Almroth Wright, that's a mouthful. So this guy developed a simple coagulation instrument, which is called the coagulometer, and this instrument was used to estimate coagulation time. He was also the first to note that calcium played a critical role in coagulation. So we had a lot of developments in coags during the 19th century. On to the 20th century. Okay. It wasn't until the 20th century, actually, that clinical labs started to become permanent units in the hospital. So during this time in the 20th century, laboratorians began to establish an identity as professionals and really started working to establish professional societies. In the 20th century, we also start to see various types of labs beginning to emerge. So we're starting to see physiological labs, pharmaceutical and pharmacological labs. We see forensic labs, public health labs, microbiological labs, and then, of course, the general hospital labs, sometimes today known as core labs. And then there were also many advances made that helped eradicate or drastically reduce life-threatening illnesses. And one of those was the discovery of insulin. So you can see this image here, Banting and Best in the laboratory where insulin was discovered. So other major advances during the 20th century included the discovery of microbial growth factor, meaning the necessary requirements for bacterial growth. So a lot of what the auger plates that we use today were this was the beginning of their development. We also determined that there was a difference between bacteria and viruses, and there was the introduction of a lot more antibiotics during this time, as well as documentation of bacterial transformation. So even though it was discovered in 1928, penicillin really became popular in the mid-20th century due to its ability to treat lots of different infectious diseases quickly. So you can see in this picture over here, I believe that's either a public trash can or mailbox maybe. It says, "Penicillin cures gonorrhea in 4 hours. See your doctor today." So they were really excited about antibiotics. They were really a new thing and starting to be produced on a larger scale to treat these different infections, apparently in 4 hours. So in the 1930s, more antibiotics were discovered. So Gerard Johannes Paul Domag discovered Prontosil in the 1930s, which was a derivative of sulfanilamide, and he discovered that was effective against Staphylococcus and hemolytic streptococcus. So we've got different antibiotics that are now able to treat different bacteria. So during this time when it was discovered that there was a difference between viruses and bacteria, we had a subfield of microbiology that emerged, which is virology. in my head, this probably marks the beginning of the debate on bacterial versus viral infections and how to treat each of those. And that debate has been ongoing to this day. Antibiotics or no antibiotics? Okay, moving on. So the 20th century, we also start to see more clinical chemistry being used in the lab. Otto Folin, for example, he introduced quantitative analytical methods for urine analytes. So that means really we start to determine the quantity of a urine analyte rather than just the presence. So instead of just is this analyte present or not present, we start to detect how much of it is present. He was also the first to use Jaff's alkaline pick rate method to test for creatinine. And he introduced a colorimetric method for measuring epinephrine. So a lot of chemistry going on here. We also have Donald van Slyke. He studied electrolyte equilibriums in different body fluids, and he also studied acidosis, which you guys will talk about in chemistry and maybe a little bit in body fluids, but definitely in chemistry, clinical chemistry. So during his studies, Van Slyke, he designed a volumetric gas measuring apparatus that determined CO2 concentration, and he introduced the concept of blood urea clearance. So blood urea clearance, for those of you that have not talked about this before, that just refers to the amount of blood cleared of urea per minute via renal excretion. So this is basically a measure, one of many measures of kidney function. And finally, for the 20th century, developments in blood banking. So remember Richard Lower from a few slides ago, back in the 17th century, he was really one of the first to start experimenting with blood transfusions, and this is in the 1600s. And he tried animal-to-animal transfusions as well as animal-to-human transfusions. Now, I don't know exactly how successful he was, but something tells me probably not super successful. But fast forward to the 20th century, and we have the first blood bank established. So in Leningrad in 1932 was the first blood bank that was established in a hospital. In the U.S., it wasn't until 1937 that the first blood bank was established. And that was in Cook County Hospital in Chicago. Now, in the 20th century, we also had the blood groups that we know and use today that were discovered. And those were discovered by Carl Landsteiner. You'll want to remember this name. It will come up in blood bank. And Cherika will want to make sure that you know Carl Landsteiner and his... Okay, so we're going to switch gears a little bit here and discuss the quality movement and the origins of the professional certification debate. Many of you that are in the field already are probably familiar with some of these debates. And we'll just kind of talk about how those came about and sort of where we're at today. So the quality movement in the laboratory. So the lab quality movement really began in the 20th century, and that was when so much progress was happening in the lab. Remember that we just talked about. So lots of advances in micro, advances in clinical chemistry and blood bank. So at the same time as that, pathologists and healthcare workers really began to identify as professionals. Hospitals started sort of reorganizing labs to make more sense, and professional lab organizations emerged as self-regulating groups. So during World War I, the U.S. started to see shortages in medical staff, and that was all medical staff, not just in the lab. And so they started hiring non-physician laboratory helpers to fill those empty spots. And many of those positions were filled by women. And this was really for two reasons. So women could be hired and pretty easily trained to be professionals on the job. But women also did not pose a threat to the authority or the economic position of physicians, and that's kind of what they wanted. So this is really when our profession became female-dominated, and if you look around in the lab, generally you see more females than males, at least in the clinical lab. And that's sort of the origin of that. So following the war, the number of clinical laboratories in the U.S. really made to establish a laboratory examining board and a national association for lab technicians, which was really the aim of that was to really bring about recognition of our field. And so just a side note here, the UAMS program was established in 1918 and is actually one of the oldest formal training programs in the U.S. When I was doing research for this topic, I also found that the University of Minnesota had a very early formal training program, and theirs was started in 1924. So UAMS program that you all are in is over 100 years old. So crazy. Continuing with the quality movement. So around the time that people were advocating for formal training programs and national laboratory associations, this is also when the first hospital inspections began. So these inspections were conducted by the American College of Surgeons, and they consisted of a single page of standards. Now, those of you that are in the field already can giggle with me at the thought of one page of standards, because we know that today there are many, many, many pages of standards. So during these initial inspections, there were 671 hospitals that were inspected. 81 of them passed on their first inspection, and another 100 passed after they made some improvements. So quick math, this means nearly 500 of those hospitals did not meet the standards, which is a lot. So in the next several years, clinical labs started becoming really distinct units in the hospital, and they were often directed by a physician. By 1923, 48% of U.S. hospitals reported having a clinical lab, so that's less than half. 1923 was not that long ago. Now, if you think about a hospital without a lab, yeah, just think about that. Does that even exist? I'm sure it does somewhere. So in the 1950s, hospitals began to be encouraged to plan for space and equipment for research and clinical labs. And they were encouraged to do that as they were developing their building plans. And along with that, the American College of Surgeons created certification standards for those hospitals with an established lab. So those hospitals then had more standards they had to adhere to that involved the clinical lab. So we start to see in the 1950s laboratory-specific standards. So quality at this time was not standardized, but as the laboratories became more regulated, quality became more consistent. So today, as we know, there are many, many regulations that the lab must abide by. And while quality has improved and become more consistent, the fight now has really moved to obtaining licensure in every state, which it's argued will improve quality even more, as well as patient safety. And that's a topic for another day. So let's move on to the origins of professional certification. So professional certification really goes hand in hand with improving quality. So the first definition of a clinical laboratory was coined in the 1920s, and this is different from the definition of laboratory science that we talked about in the beginning. So remember, laboratory science is a discipline, and the definition of clinical laboratory is really defining that space. So the definition is a clinical lab is an institution organized for the practical application of one or more of the fundamental sciences by the use of specialized apparatus, equipment, or methods. So we can interpret tests, but we do not diagnose patients. We can tell the physician that this bacteria is susceptible to this antibiotic, but we cannot tell them how to treat that patient, right? So these ethics are really still in place for our profession today. As a side note, ASCP during this time was called the American Society of Clinical Pathology. Later, it becomes ASCP, the American Society for Clinical Pathology. Also, the ASCP Board of Registry today is known as the Board of Certification, the BOC, which is the exam that all of you will take to become certified medical laboratory scientists as soon as you complete our program. And all of you will pass. So after the ASCP was founded, the American Society of Medical Technologists was formed as a subgroup of the ASCP. So it was established for non-physicians. So remember, ASCP is for pathologists. It was formed by pathologists. And so the ASMT was formed for non-physicians. They very quickly after they were formed implemented a process to certify medical technologists. But it wasn't until the 1940s that ASMT was given 3 seats on the ASCP board, which was previously restricted to only pathologists. So eventually we did get some representation on the board. So around this time, the 1940s, accreditation of education programs also began. So we start to see these formal training programs. Now they're being accredited, meaning they are up to certain standards. Now, side note here, ASMT was initially a subgroup of ASCP. Now it's AMT, which is the American Medical Technologist, and they still give a certification exam that certifies as a medical technologist. If you're not confused by all these titles yet, you will be. Just give me some time. Okay, so let's jump into the 1960s. We're going to jump ahead a little bit. Professional certification efforts in the 60s continue, and we really start to see more regulation efforts begin. So in the early 1960s, a baccalaureate degree was added as a qualification for certification by the ASMT, which was still the ASMT at the time. So in 1965, we see Medicare and Medicaid signed into law, and shortly after that we have the first CLIA, which is the Clinical Laboratory Improvement Act. So in 1967, when it first comes out, it's Clinical Laboratory Improvement Act. CLIA was introduced, and initially it established quality requirements only for clinical labs doing business across state lines. So in reality, this really only accounted for a very small percentage of U.S. labs. At the same time, we see the National Committee for Clinical Laboratory Standards starting to work to standardize all laboratory test methods. So we're starting to see the beginning of standardization. Side note, the National Committee for Clinical Laboratory Standards is now CLSI, Clinical Laboratory Standards Institute. And those of you, I have seen mostly CLSI guidelines in microbiology, but they do exist for the other departments as well. And you will often see those guidelines in the lab. So know that those started around the 1960s. 1970s. So now we have more national agencies being formed. We've got continuing education requirements being introduced, and we've got amendments being made to the Social Security Act. So the National Accrediting Agency for Clinical Laboratory Science, which we call NACLS, you've heard NACLS in regards to our program before. So NACLS was formed as an independent organization responsible for accrediting lab science education programs. This agency still exists today and is still accrediting education programs. So every MLT, MLS program that is accredited gets to re-accredit through NACLS every so often. So you can be awarded up to 10 years of accreditation. And they will come and visit you and look over all your curriculum, and they basically accredit your program to say that you are meeting certain educational standards. So, 1970s. We also have the ASMT, remember, formed as a subgroup. They formed a subgroup called the National Certification Agency to advance certification efforts. But during the same time, we've got amendments being made to the Social Security Act, and those actually probably made a bigger impact on certification and requirements for MTs than the NCA did. So the amendments that we see in the Social Security Act include QC standards that must be implemented, requirements for proficiency testing, and more personnel competency rules. So it made these requirements mandatory in order to receive Medicare funds. So what better way to make sure that people comply with regulations than to make it mandatory for you to receive reimbursement? And so on this slide, you will note that MTs were required to have a bachelor's degree or pass a proficiency exam administered by HEW. HEW is the Department of Health, Education, and Welfare. So they actually developed a proficiency exam for those that had been in the field but didn't have, had not gone through a formal education program. And the requirements to take that exam included a high school diploma and at least 4 years of lab experience. Okay, so as a group, our profession began to be more involved in national politics in the 1980s. This is when CLIA was amended and became the CLIA we know today. And the CLIA we know today is the Clinical Laboratory Improvement Amendments. So no longer the Clinical Laboratory Improvement Act, but now amendments. So according to these amended CLIA regulations, all labs are required to have a Department of Health and Human Services, or HHS, certificate. And to get this certificate, labs are required to have a quality assurance and quality control program in place, and they have to have a record of successful proficiency test pass rate. So they must be passing a certain percentage of their proficiency test in order to obtain this certificate. So CLIA 88 also developed the categorized testing that we all know today, and they defined the different tests as either waived, moderate complexity, or high complexity. And we'll talk more about this when we talk about CLIA, and it will also be covered in the CLIA boot camp. So based on the different testing levels, that's how they determined what requirements and qualifications were necessary for testing personnel. So the requirements and qualifications for performing wave tests are different than those for moderate test or high complexity tests. So in the 1990s, ASMT, which was once a subgroup of ASCP, split off. They became ASCLS, which is the American Society for Clinical Laboratory Science. And I believe the NCA actually was the one that split off and became the AMT. So as ASCLS, that group actually joined with the American Association for Clinical Chemistry, or AACC, to hold one of the largest national meetings for lab professionals that has ever been held. They held this meeting. It was an annual meeting, a national conference, until last year. So actually 2018 was the first year that the two groups split, and ASCLS actually joined with another group, a genetics group, to hold the national meeting, and AACC actually holds their own meeting now. So around this time we start to see a lot more conferences, national conferences happening too. And in the mid-90s, 1995 actually, this is when the National Labor Relations Board finally recognizes medical technologists as professional employees. So what about today? Today, we actually still have an identity crisis in our field. So as I was saying, there's so many different titles. There are several different certifying agencies. There are multiple professional organizations, some of which kind of don't like the other. They don't get along so well. There's kind of a lack of unity among our profession. Some states require licensure, but most do not. We are very much considered a hidden profession because we work behind the scenes and we don't have direct patient contact most of the time. But this identity crisis that we are dealing with right now is really adding to the lack of recognition for our profession. Now, that's not to say that we don't get recognition, because we do, but we could be better recognized. You know, if we can't decide what to call ourselves, how can we expect anyone else to know what to call us? So today we're kind of still dealing with the outcomes of all of these different organizations and all of these different titles that we've been given or taken on. So in the future, I challenge you guys to really kind of try to bring our profession.
Перспективи розвитку лабораторної служби. Перше – це технологічний прогрес, впровадження передових технологій та автоматизації для підвищення продуктивності та точності аналізу. Друге – диверсифікація послуг, розширення спектру лабораторних послуг для відповіді на зростаючий попит та потреби клієнтів. Третє – якість та стандарти, забезпечення відповідності міжнародним стандартам якості та безпеки. Четверте – навчання та розвиток персоналу. Інвестування в навчання та розвиток персоналу для забезпечення високого рівня професійності та компетентності. П'яте – цифрова трансформація. Впровадження цифрових систем керування даними та звітності для підвищення ефективності та швидкості обробки інформації. Шосте – стратегічне партнерство. Розвиток партнерських відносин з медичними установами, фармацевтичними компаніями та дослідницькими центрами для спільної розробки та впровадження інноваційних рішень. Сьоме – сталість та стійкість. Впровадження стратегій для забезпечення стабільності фінансових показників та відповідності законодавчим вимогам. Дякую за увагу.